What's up, guys? Long time no see. Um, let's just dive right into this. I'm sure you've noticed some very peculiar things right now. Um, Mostly the significant pile of electronics right here and this huge spool of cable and a microwave transformer. This is my introduction to my next big ecig project, because who knows when we're going to be able to get this stuff going. It's actually going to power this box from the microwave transformer, but we're going to get the transformer system going first. So we're going to explain what I'm going to do here. This ice cold Mountain Dew. Okay, so I've been thinking about this all afternoon. How the heck am I going to explain what's going on here? And I think I'm just going to dive right into it, and if I don't like it, I'll scrap the video and start from scratch, which is a pain, but it'll work. So let's begin with the transformer. This is a microwave oven transformer out of a large 1200 watt microwave oven. It is fully functional. I have tested it. The 2000 volt output is ridiculous and lethal, and nobody should ever mess with one of these, realistically, ever. There are ways you can make yourself safer, but you can never truly be safe working with a ridiculously high power, high voltage. It's still a lot of current, and there's no way to limit. There's really no current limiting here. It's just gonna dump the power into whatever it is. And at 2000 volts, if you're not well insulated and it's not well grounded, you're just begging for trouble. But anyways, we're going to cut the high voltage side off of this and rewind it with 14 gauge. I have far more than I need, which I planned it that way because I wanted to have enough to make a significantly long cable for it after the fact. So there's that. I could have gone with a larger gauge wire or lead wire and gone for a lower voltage. I'm shooting for around 14 to 15 volts here. If I come out higher than that, that's great, but I don't want to come out any lower than 14 volts because, and we'll get to that in a minute, it's going to have a DC output side, and I am going to lose some voltage through the bridge rectifier. But I will still get 1200 watts of power even at 14 volts. It's just going to be less current than it would be, say, at the first microwave transformer, 9.75 volts. It's still going to be far more current than I will ever need. I will probably never get this close to the 1200 watts simply because it's unnecessary. So with that being said, my first microwave oven transformer, I actually sold it or traded it to West Tulsa Vapor, which I've talked about in the past. I may have even told you guys I sold it. I forget. It's been a minute. Traded it for the Smoke GX350 and TFV8 kit, which I have used almost exclusively. I've put the Maximus on this a little bit. It overhangs over the screen. I had to make an adapter that spaced it up so it would not destroy the screen. And you couldn't see wattage settings, battery, or anything because the Addy's so much larger. Which is, it is what it is. But it is 350 watts, and I have run it to its full 350 watts on the Maximus, and it worked great. It worked exactly as I expected it to. Got quite warm. Very, very warm, uncomfortably so, but it did it. On the TFV8, after using up the 2 stock coils in a week, I put the RTA in it, and I have been exclusively using dual coil 26 gauge 10 wraps on I think it's a 3/32 bit. It might be larger than that. If so, only just barely. Dual coils right at anywhere from 0.35 to 0.4 depending on how I build it. This one's right at 0.36 ohms, only running it at 30 watts. And with a freshly charged set of Samsung 25Rs, I can go 2 full days without having to do anything to it except fill it with fluid. And it's awesome. That is what most people are looking for. And this thing is little. I could not believe how small. And of course, when I filled it before the video, I kind of got a little crazy with it and it leaked a little bit. The form factor on this thing is much, much smaller than I expected. It's barely large enough for the batteries and components. They did a good job designing this thing. But all that aside, I love this thing. Works great, especially with the simple dual coils. Back to the big one. Still running 120 volts AC because it's a transformer. It's got to have that power. The first one was pretty much stuck at 9.75 volts. The last voltage reading I took on it was 9.74 volts. A tenth of a volt discrepancy. Or hundredth of a volt, my apologies. But I couldn't adjust it. It had a foot switch, which I really enjoyed, but was kind of a pain working around, especially if I was working. It got in the way a lot. I actually tried to use it at work quite a bit, and I liked it, but especially at work, it was a pain. So, my first task was to find a housing that I could fit it in, and of all things, my grandpa showed up at work today with this big wooden box, which is significantly larger than needed for the transformer. It's going to allow for plenty of room and plenty of heat dissipation. Very nice box. We're going to insulate the whole thing inside and set up a solid ground bus bar inside of this thing. Everything is going to be grounded. As I said, the first one was a prototype proof of concept. Didn't even know if it was going to work. I plan to use this one forever or sell it for the right price if the right price comes along. So I want it to be really, really solid. I had a small rheostat. Well, I say small. It was a 300 watt rheostat for the original that I never installed. And after testing it, I discovered that it was shorted out. So I found 2 others that I have sourced. I believe this one is rated for 2.07 amps at what is this? Oh, where's the voltage on here? It's something like 700 volts or something like that. And this is a smaller one. This would not be technically speaking, it's rated for the wattage. I don't know how it would handle the current. However, this one is more than sufficient. This is rated at, this has actually got a stamp on it. This is a 64 ohm, 0.9 minimum amps. Does not have the maximum on this. I forgot it did not have the max. But this will do it. I would say about 75% confident that I'll have no issues with this. Obviously the shaft is a little large, we'll have to cut that down. But we can mount this through hole and mount a knob on the outside, make a voltage dial on it, which I'll probably put some form of dial, but I'm going to put a voltmeter and an amp meter in this for AC, and because I intend to use this with a DC output, a split off of this for DC use, I'm also going to put a DC amp meter and a voltage meter on this. I'm going to have to hunt for those. I'm not sure what I'm going to be able to find yet. I also sourced 6 I believe these are 60 amp diodes. These are actually rated up to like, I think their working voltage was 600 volts or 650 volts. I don't remember exactly. These are used in a 460 volt three-phase generator. That's why there's 6 of them. You've got 3 sets of 2, positive and negative diodes. But these by themselves are going to produce a ton of heat if I put any kind of power through them. So I've got 2 sets of aluminum heat sinks here. These also are not incredibly beefy. I'll mount a basic bridge rectifier diode assembly onto these heat sinks, and I'm going to put a forced air cooling system into it using these 2 turbine fans. Now these are 12 volt fans. The power coming out of the transformer is going to be 24 volts, so I will connect these 2 in series, which will effectively give me a 24 volt fan out of 2 12 volts. Also, for whatever transformer I decide to use, which I have the original control board out of the microwave, which has the transformer as well as 2 24 volt relays, which were actually designed to power the transformer. And this one's actually 24 volts DC, 16 amps. And I can't see the other one because it's covered, but I believe it's the same ratings. So that's probably what we'll use, just because it's easy. I do have a larger copper heatsink if I need it for individual cooling of something, probably the smaller transformer. Not sure how I'm going to hook all that up yet. But as you can see, I very much want this to be a very solid system. I don't want any chance of failure. I don't want any chance of harm. There will be 2 outputs, the AC output and a DC output. DC output will probably be like binding posts that you would have on a standard variable voltage, variable current power supply unit. Oh, the voltage and current meter that I'm trying to use, you may recognize this. This was the top half of my lithium ion charger that was also a buck converters, 100 watt. I blew the MOSFET up in the regulator side, but this is nothing but a voltmeter and amp meter. I have a high current resistor. I think it's a 1% is what it has to be, accuracy resistor for the current meter on this, which means that I can technically measure much higher current than it was originally designed for, as well as up to, I believe this was rated at 35 volts. So I have DC current and voltage meter here, which I'm really excited to get going as well. So obviously the DC output side is not going to have the same kind of power as the AC side. There's a lot more components involved. You're going to lose a lot of power through the bridge rectifier. But it's still going to be awesome. And of course I'll have a full bypass, which will bypass everything and just give me the straight full power from the secondary coil. If for some reason the rheostats cannot handle it. Everything will be grounded. Everything that needs to be grounded will be grounded. I don't want to take any chances with it. I've even considered running a ground up to whatever device I'm using, but that would be I'm not exactly sure where I would put it, but it was considered. I actually got a lot of feedback on the last 120 volt AC microwave transformer videos that I did. They were some of the more popular videos that I've done recently, and I was really surprised. Hopefully, when all of this is said and done, I will have a badass, fully regulated approximately 14 volt AC power supply and 14 volt DC power supply. AC side up to about 1200 watts. I calculated the DC side up to about 500 watts, which is still ridiculous. But the DC side, being able to adjust voltage and current simply by controlling the input on the microwave, will allow me to use it as a variable voltage power supply, and potentially variable current. Not going to be able to set a constant on it unless I'm actually using a constant load. But it's going to have a lot of uses. And with the DC side, I'm not going to go there. I've looked at doing the TIG welder stuff, and I have 3 of the massive diodes necessary for that. But unfortunately, we didn't have a 4th one, and for a full bridge rectifier. And I think there's a way I can get away with 2, but we'll just have to see. I may replace these little ones with the giant multi-hundred amp diodes, which would still be overkill for the output because it can't put out that much kind of current. But anyways, getting off topic a little bit there. I am very excited to get this going. I do intend to document the entire process. It's going to be very tedious, but it's worth it. I hope you guys will follow along on this build. I will hopefully have the first part out here by the end of the weekend. The actually cutting and rewinding the transformer is the first task. Can't do anything without the transformer. Now, if I can find 120 volt to 24 volt transformer in the meantime to give me a more powerful transformer, that would be ideal, because that would allow me to I mean, I'm sure this one's fine for the microwave components, but I'm not sure how well it will hold up driving a few other items such as the fans and such. They're actually quite powerful. These are 0.35 amps each, which at 24 volts is still only going to be 0.35 amps. But at a third of an amp at 24 volts, you're looking at 8 watts. Yeah, about 8 watts of power on top of driving the relays. So I'm not sure if it'll work or not. We can try it. I mean, at the very least it'll blow up and I'll have to replace it. I'm very excited. I am very, very excited about this. This is going to be awesome. I may be able to incorporate this into the DC side on the output, specifically to set DC output voltage without having to change the output voltage of this, which would be awesome. That would save me a lot of trouble and take a lot of load off of some of the other equipment. We'll just have to see. It's a big box, but it's going to fill up quick. Oh, I almost forgot the most important part of this whole video. This old AGM PSU battery. Backup power supply unit battery out of a really, really old one. This is only a 7.5 amp hour, 12 volt battery. Lead acid. I recently discovered someone by the name of John Bedini. Might as well be John Houdini. Dude's awesome. Dude has got some brains on him and a lot of very solid testing to back it up. He has designed some amazing lead conversion batteries using old lead acid batteries, removing the acid and replacing it with an aluminum sulfate solution of distilled water and alum, which is you can buy it at your grocery store. It's the pickling juice, the stuff you make pickle juice out of. Awesome stuff. And low current, not low voltage. It's slightly lower voltage than the initial cells, depending on how you make it. Usually about 1 to 2 amps output max. I have seen tests showing a significant increase in capacity, even if it doesn't change the capacity. If I can make it work in one of these batteries, I could build a smaller one, which is rechargeable, to charge a supercapacitor bank to build a portable mod out of it. You could use a low power battery to keep the capacitors charged and use the capacitors to vape off of. Talk about awesome. Completely unregulated, of course. You don't need regulation on something like that. That's actually going to be a fairly easy process, and I'll be doing that in the meantime between this. Probably not going to track the process on this, simply because I've never done it before, but I will keep you guys updated as we go. So stay tuned. We got a lot coming. Very quickly, I'm going to be ordering all of the materials necessary to make approximately a dozen tube mods. I will be making them at work. I will record the process probably for the first one, or probably the second one after I get it sorted out. I've got a locking mechanism designed. Just got to see how well I can implement it on my first tube mod. If it will work well, then I can go ahead and use it on the others. When those are finished, I'm going to put them up for sale. Probably not going to charge more than $100 a pop for them. I'm going to put some serious effort and time into these things. I really want them to work out well. And I will let you guys know when that's available. Probably just going to sell them on eBay because it's the easiest way to do it. I've already got a handful spoken for locally. I'm going to use those to fund getting a lathe, and if I can get a dozen of them made, we'll be set. I decided on aircraft grade aluminum for the actual tube body, and then hardened brass, or half hard brass technically, for the top and the switch, and then copper pins. On the actual body of the tube, in the testing that I have done with the aircraft grade aluminum that we have at work, machined to the same dimensions, not with threads cut in it, testing it with our, I think it's $30,000, our high-end surge tester, which also tests ohms down to the, is it 10,000th of an ohm or 100,000th of an ohm? I don't remember if it's 5 or 6 digits. Anyways, ridiculously high resolution on the resistance. I cannot get an appreciable difference in current or in resistance between copper, aluminum, or even my naval brass, which works really well. That may be a different story when it comes to current carrying capacity. I highly doubt it. I think the brass top and bottom and the copper pins is going to do far more for power than the actual tube body itself. We'll see. I don't know. We'll build the first one. We'll test the crap out of it. And if it works well, I'll finish them up and I'll put them up for sale. So stay tuned. We got a lot coming. It's probably not going to be as quick as you guys would like. Not going to be as quick as I would like either. It's all got to be done in my spare time. But stay tuned. We got some big things in the work. Vape on, guys.